a statement that disproves something. Very good. A counterexample is a statement that disproves something. A counterexample doesn't have to be anything fancy. All students take science while they're in high school. Yes, sir. I'm trying to think of a different way to write it. All students. Yeah, that's a great one. All pencils are yellow. Exactly. That's a good one. Thank you. I can use it when we're later. All dry erase erasers are blue. Right. Yeah. Yes, ma'am. Okay, so example. Here, let's say this is our statement. We'll go back to the farmer one. That was pretty easy. All farmers if I want to come up with a counterexample to that, right? What's something that disproves that? What could they plant? Okay, you can say this. Some farmers only plant carrots. I just made a generic statement. I am not trying to. You guys are overthinking it. You quite literally, some plant just carrots. Some are wheat farmers. I don't know. Some just. Yeah, I know. I'm just trying to think of something like that. Remember when we did this with, and this is counterexamples led us into what were called conditional statements. Yes. And then we used counterexamples in conditional statements with the P's and Q's and all that stuff. So after this was the 2.1-ish things, then we got into 2.2, and that was your conditional statements. Where you took a generic statement and turned it into an if-then. Let's see. A conditional statement, if you start with something generic, try to read one here. All right. Turn this into an if-then statement. All motorcyclists wear helmets. If you're a motorcyclist, forgot the then. Then you are out. Perfect. So if you start with a generic, if you start with the statement, all motorcyclists wear helmets, and you want to turn that into a conditional statement. A conditional statement is your P implies Q. Remember that? If then. If you are a motorcyclist, I was going to abbreviate so I have space, then you wear a helmet. Okay. When we did condition, then we got into all the different versions of it. Conditional, converse, inverse, contra clausic. Yes, sir. What this was just saying, this is something without an if-then, I'm asking you to turn it into an if-then. If the statement was all motorcyclists wear helmets. If you're a motorcyclist, then you wear a helmet. That's turning that into a conditional statement, okay? Without adding any other words. All I'm doing is putting an if-then into it. When we did the 4 versions, this was your conditional. Your converse did what? Yes, ma'am. But you're adding words. Don't add words to it because it's going to mess up the rest of the statements. Watch what happens. Yes, ma'am. Correct. Now, remember, we did those 4 versions. You went conditional, P to Q, converse was Q to V. So you say this backwards. If you wear a helmet, then you are a motorcyclist. We have to go back to the original statement here in 1 second. If you wear a helmet, then you are a motorcyclist. And I forgot to do that with my first piece. Every time you do conditional, converse, inverse, positive, for every statement that you state, everything that you write, you have to say whether or not it is a true or false statement. If it is false, you have to come up with that counterexample. So if I go back to our conditional, if you are a motorcyclist, then you wear a helmet. Is that true or false? False, because why? Correct. This would be false, and your example would be not everyone does. Okay. The converse of that, if you wear a helmet, then you're a motorcyclist. True or false? False. What's your counterexample? You could be a construction worker. You could be a bicyclist. Yeah, that's perfect. False. I like the construction worker. I didn't think of that one. That's good. Bicyclist. You could be on rollerblades. You could be on a skateboard. You could be snow skiing. People wear helmets to do that. Yes, sir. I'm sorry, I couldn't hear you. What's that? Oh, no, you could have done it here. If you're a motorcyclist and you wear a helmet, false. Construction worker wears a helmet. They might not be a motorcyclist. See what I'm saying? It could have been anything in there. Whatever comes to your mind that works. There are many different ways that some of these things will work. Okay. Converse, then we did inverse. Inverse was the not good. Very good. Not P, not Q, which means that you just have to put the word not into it. That was your not. I'll use the tilde because I think what not P implies not Q, which means if you are not a motorcyclist, then you do not wear a helmet. Is that true or false? That's false again. You could be a spelunker. A person. I'm just thinking of funny things. I thought spelunking sounded funny. Now, I'm sorry. What's the point of wearing a helmet if you're skydiving? No, I got you. I didn't think of that. I mean, okay. Yeah. Okay. All right, I'll give you that one. I didn't think of it that way. I just think of. You just got Yeah, I would imagine you probably put those little earplugs in there. So again, is this true or false? False. So we can just. What did we say? Skydive. I mean, honestly, could I have used construction work and could I identify some? Yeah, absolutely. You can reuse the same counterexample because it happens a lot. Remember the one we did earlier when we first introduced this, where I said if you are a teenager, then you're 13, and then we said false, you could be 15. And if you, yeah, let's go on from there. And then the last one was the contrapositive. That was the not Q implies not P. So if you do not wear a helmet, then you are not a motorcyclist. Oops. Sorry, my handwriting gets bad. If you don't wear a helmet, then you're not a motorcyclist. Now, this statement, to think of a counterexample, I would go back to saying that there are motorcyclists that don't wear helmets. So if you don't wear a helmet, then you're not a motorcyclist. Well, there are motorcyclists that don't wear helmets. There's no helmet law in Illinois. Contrapositive, yep. Yes, sir. I think if you're underage, I believe so. There are certain rules depending upon where you're at. If you're at a park, some of the there are certain four-wheeler parks. I think there's one out towards Belvedere. I think you're required to wear them there. I know that there are certain safety things in Wisconsin, I think with snowmobiles you have to have a helmet through. I know that in Illinois you don't have to wear a helmet on a motorcycle. Why you wouldn't wear a helmet is beyond me. I think Florida is a law you have to have a helmet, but the helmet laws in Florida and in California are so light that they're not even. I mean, the helmets, they just have to have a DOT sticker on them. DOT sticker, I could take something this thin, form it as a helmet, put a DOT sticker on it and wear it. It's just not going to protect everything, but I don't know. Anyway, so I would say not all motorcycles wear helmets. There's no helmet law. There's no helmet law in Illinois. Obviously, you didn't know that, but whatever. You can come up with it. That's what it meant when we did converse, inverse, contrapositive. All we had to do was just go step by step by playing around the letters. Remember, P implies Q, Q implies P, not P, not Q, not Q, not P. It just flips back. Okay? That was everything in, what, 2.3 then, I think? 2.2, thank you. 2.4 was the deductive reasoning. 2.4 was your law of detachment. And the law of syllogism. Okay? Now, when we did detachment, that was if Moose eats a pizza, then he has a Sprite. Moose ate a pizza. Is there a valid conclusion you can get from this? What is it? Moose had a Sprite. Okay. The idea of the law of detachment was you had an if-then statement to start with. After you did that conditional, the second sentence, if it tells you the if part was true, the next sentence you write is the true part of the thing. So the final answer would be moves heads right. Okay. Law of detachment, if you remember when you read those, it just sounded choppy. Okay, it just sounded choppy. Whereas the law of syllogism or the transitive property is kind of the same thing. Law of syllogism, I think the easy one we did was Tom is taller than Bob. Bob is taller than Sue. Therefore, what can you say? Tom is taller than Sue. It's that law of syllogism, or what we call the transitive property, has that repetitiveness. What you end the first sentence with, you start the second sentence with. What you end the first sentence with is what you start the second sentence with. It is very, it's smooth. I think it's very, it's a smoother sounding setup than the detachment. Moose has pizza, he has a Sprite. Moose had a pizza, Moose had a Sprite. Tom is taller than Bob, Bob is taller than Sue. There's the repetitiveness. The repetitiveness. That was 2-4. Again, you guys did really well on that stuff. That was pretty simple. Then the last little, well, almost last bit, is I think it was 2.5. And that was, all we did in there was the algebra proofs. And I don't think we even called it 2.5. I just know that if you had to go back and reference anything, that's where some of that stuff was located. The algebra proofs we will come back to starting next week on Monday, because we'll start talking about algebra proofs in terms of segments, algebra proofs in terms of angles. We'll probably take all of next week to do that. Okay. So in terms of algebra proofs, it was basically starting with statements and reasons. And you had something like you had something like that. And then from there, you had to make a decision. What did you want to do first? Distribute. Okay. So if we go to the distributive property, we would just write out the little arrows that I know go to here. So I have 2x minus 2 plus 4 is 16. What was the reason that I did that? You just said it. Distributive property. So on your reason bank, which you can use, you have your distro problem. Okay. Now what? Simplify. Good. So I would write 2x plus 2 is 16. Reason. Simplify. Now what? Yep. Minus prop equal. What's my next one? Can you have multiple simplifies? And last but not least, and if you guys remember, These are really easy, but it helps you guys, it'll actually, the premise that we always start with algebraic proofs is to get you guys accustomed to organization with sequential steps. Okay? As we learn how to get organized with your steps in a nice, specific, clean order, everything else, when we get into working with the segments and then angles, becomes easy. Right? It becomes a lot easier. And that's what you did for those. Okay? And then the last little bit of stuff was what you did Tuesday. And that was the 4.1 where you basically had a congruency statement. Triangle ABC was congruent to triangle XYZ. So whether or not you have a diagram, you know what specific parts match to specific parts. So if you had to do something algebraically, you could figure out. If you had to list things, you could figure that out. What's that? Yeah. So revisit this then. Congruency means they are equal measure. So if I'm just looking at it, I know I don't have a picture, I know I don't have the algebra here, but if I look at this statement and I want to list my angles, what does angle A have to be congruent to? X. Just follow the correspondence with the letters. What does B have to match up with? Yes, ma'am. Like show that it is? Oh, it depends. The problem could have a picture, it might not have a picture. It depends on, because there's different things you can do with it. I could ask you to list what matches up. I could ask you, I could have a picture here. I could have something like this and call this one figure out what Z is. But then you have to understand how the correspondence works. So no matter what, if you have the letter, as long as you understand the lettering, I know you guys can do the algebra. The algebra stuff you've done is really simple. I'm not worried about that. But what does B have to match up to? Y. Okay. So knowing how many degrees are in a triangle is helpful. How many degrees in a triangle? All right, so if I back out 65 and I back out 70, how many are left? 45. That makes this 45. And since C and Z are the same, what's Z? 45. It's that kind of stuff. Can you get the correspondence to go back and forth between measures? Right. That's the kind of idea. If you had to do segments, if you had to list out segments, segment AB has to match up with what letter? XY, good. If you did segment BC, YZ. Now be careful with this one. If I write down CA, I start at the end and I go to the front, which means I have to do the same thing with the other letters. Z, X. Now remember, I know that ZX and XZ, they're the exact same segment. Segment lengths are the same going both ways. But when we talk about proof stuff, we talk about congruency statements, the lettering in the order, the order of the lettering has to match. That's the important thing. That's the big kick out of all this stuff. It's more specific than if it did not. It's one of those, it goes back to the idea of, remember I called that math etiquette? It's that math etiquette where you have to match things up cleanly just in order to make sure it works. Okay? And then from there, that was pretty much it. There was just a couple little algebra things out of there. There wasn't anything fancy. Okay? I'm not going to have you guys do any prove the whole triangles are congruent or anything like that. Yeah, we're not ready to try to. Yes, ma'am. Yeah, absolutely. I don't know if there's anything out there yet that we're going to worry too much about, but for your to get used to it, that's fine. But what I do want you guys to do for tomorrow, I'll give you a little bit of time to start up on this so you can screenshot it, whatever. And I'll plug this at the beginning. On page 130, I want you to do numbers 12 through 19, and then 27 through 30. And on page 274, 5 through 14. A couple of those are really straightforward. A couple of them have the same one diagram for a few problems. But it's all review. Everything on there is review. Everything is extraordinarily straightforward. There's a textbook up front here. If you want to take a picture of it, please, by all means, go for it. Otherwise, I would take out my Chromebook right now and start screenshotting it so it's there in case I lose internet later. Because then we have so we'll quiz this stuff tomorrow. Then, like I said, starting Monday, we're going to get into using algebra to prove segments congruent. That takes usually a couple of days. Then we'll do angles for a couple of days. Depending upon where we're sitting, we might do a segment and angle quiz next Friday. But it's all depending upon how close or how far we get. Usually it works out.